Okay, so let's look at how to simplify a radical, such as the radical the square root of 24. And this is how we do the ones in your notes. So this process that I'm going to show you is going to actually work for all radicals, cube roots, fourth roots, square roots, you name it. So we're going to work with the property that anytime you have, for example, a perfect square, a square and a square root always cancel each other out. Additionally, a cube root and a cube always cancel each other out as well. So we're going to work with this property to help us out with these. Okay, so we look at the number, the radicand, underneath the radical sign. This is what we're trying to simplify. And by to simplify a radical and put it into simple radical form, we want to extract any perfect squares that might be in 24. So to do that, I'm going to go and I'm going to take the 24, write it off to the side, and I'm going to draw this line. So way back when, you might have done factor trees, otherwise called prime factorization. And what we're going to do is we're going to take 24 and break it down into a product of prime numbers. So our smallest prime number and the easiest prime number to start with is always 2. So anytime I have an even number, what's nice about it, if I have an even number, I know it's automatically divisible by 2. So I'm going to put that out there on the side. I'm going to take that number now and divide it into 24, leaves me with 12. So my result of my division is here. So now I have another even number. So anytime I have an even number, again, I'm going to continue to divide by 2. 2 divided into 12 gives me 6. Another even number. That gives me another 2. 3. The only thing that goes into 3 is 3. 3 divided by 3 leaves you 1. So I'm going to continue this process like this until you get down here to 1. What you're left with, right here, are all the prime numbers that equal 24 when you multiply them. So hence 2 times 2 times 2 times 3 is equal to 24. Since I'm looking for perfect squares, I'm looking for any factor that has been repeated twice. It looks like I'm repeating 2 of the 2's twice. So I'm going to come back over to my problem and I'm going to rewrite my problem. So I'm going to write this as 2 squared times 2 times 3. So I'm not changing the value of 24, I'm only changing the way 24 is appearing. So 2 squared times 2 times 3 is still 24. Now another property that we're utilizing for this is we're utilizing the property that the square root of a number, two numbers underneath that are being multiplied, can be broken up into 2 separate square roots. It's one of our properties of radicals. So as a result, I'm going to take the square root of 2 squared, and I'm going to leave 2 and 3 underneath here. Well, utilizing this property right here, that tells me the square root of 2 squared is 2. 2 and 3 I can't do anything with, so I'm going to leave those as the product of 6. And then this 2 on the outside and the square root of 6 are being multiplied together, so I can put a dot or you don't need to. And as a result, that is your answer in simple radical form. The square root of 24 is the same as the square root of 2 times, the square root of 2 times the square root of 6. So I can use the same process for cube roots. Okay, so I'm going to be looking for anything that is a perfect cube. Perfect cubes are going to be any number that is repeated 3 times. So back to the same process, the 72. I'm going to start taking my 72, and I'm going to divide it again by my smallest prime numbers. I'm only ever going to choose prime numbers. Again, half of the numbers in the world are even, so hopefully most of your numbers are even. So 72 divided by 2 gives you 36. 36 divided by 2 gives you 18. 18 divided by 2 gives you 9. 2 doesn't go into 9, but 3 certainly does. 9 divided by 3 gives you 3. 3 divided by 3 gives you 1. Remember, you are not done with this process until you get that 1. Everything that's left over on the right-hand side, that is your equivalent to 72. You can check it in your calculator. 2 times 2 times 2 times 3 times 3 will equal 72. So now what I want to do is I want to find now any number that or factor here that has been repeated 3 times. In this case it has been your 2's. So I'm going to rewrite this as the cube root of 2 to the third times 3 times 3. 3 is not being repeated, so we can leave it as 3 times 3. We're actually going to change it to 9. I'm going to use my property that allows me to break this apart. So 2 cubed, the cube root of 2 cubed. And then we'll just write this as the cube root of 9. Again, I multiply these together because there's nothing else I can do with them. They're not perfect cubes, so you can put the product back together in this case. So now, this little guy, we use that property that a cube and cube root cancel each other out. This leaves you with 2 cube roots of 9. And that is your answer in simple radical form.